Okay, folks, welcome back. Let's pick up where we left off, section 5.2, inverse functions. We are on page number 3. So again, we were asked to take a look at the inverse of each of these functions, and I'm going to go ahead and do my procedure to start by writing y equals f of x. And then I'm going to switch x and y. Okay, now I'm going to speed things up and finish this off to get the inverse for this function f. Okay, folks, here's the inverse of f. So I'm going to go ahead and label it as such. This is equal to f inverse of x. But there's really more to the story. So let's go back and take a look at the original function f, and I'd like to talk about its domain and its range. First of all, the domain for this function, if I take a look and set 3x minus 1 and say that has to be greater than or equal to 0, 3x minus 1 has to be greater than or equal to 0, that's going to give me x has to be greater than or equal to 1/3. So that is the domain of my original function. If you recall, the domain of the original function is the range of the inverse. So the range of this function is going to be y is greater than or equal to 1/3. Okay, so now let's talk about the range of this function f. Well, the smallest f can be is the thing under the square root could equal to 0. Square root of 0 plus 5 is 5. So the range for this function is y is greater than or equal to 5. So that becomes the domain of my inverse. X has to be greater than or equal to 5. So this is an important piece because we know that the graph of y equals this 1/3 x squared minus 10/3 x plus 26/3. That's a quadratic, so it's a parabola. And we know that it by itself is not invertible. But if I restrict the domain to x greater than or equal to 5, I'm only looking at a piece of the parabola which would be inverted to give you this graph right here, the square root of 3x minus 1 plus 5. Okay, so let's move on and take a look at part D here. All right, folks, there's our inverse, 1/3 x to the 5th plus 1/3. You may have also chose to write this one as follows, x to the 5th plus 1 all divided by 3. They are equivalent. Let's go back and talk about the original. I have a 5th root. I know that I can take odd roots of either positive or negative numbers. So the domain of this thing is all reals. The domain of that thing is all reals, so that will also be the range of my inverse. The range of this function will also be all reals. There's nothing in there that will limit the output of the function. And that means the domain of my inverse is all reals. All right, let's move along here and look at part E. Oh, this is good, folks. We got our first quadratic we're going to look at with a restricted domain. So the domain here is restricted to x has to be greater than or equal to 5. So I want to make a comment about this right at the get-go. There's two different ways to look at a problem like this. And I'm going to talk about an algebraic approach, and then I'm going to talk about a graphical approach. So first, let's talk algebraically. If x has to be greater than or equal to 5, that means the output of f inverse of x, that has to be greater than or equal to 5. So I'm going to come back and talk about this in a minute, but first I'm going to do all the work to find the inverse of this quadratic. All right, so the trick to figure out the inverse of a quadratic is we have to resort back to an old friend, and that's completing the square. And the reason why is because I want to find a way to get y all by itself, and completing the square will enable me to do that. So what I'm going to do here is complete the square on y, and I know in order to do that I need to take half of negative 10, that's negative 5, and then I square it. That gives me positive 25. So I'm going to add 25, but don't forget you have to do it to both sides of the equation. Okay, so let's see where we're at now. I have x plus 25 on the left. On the right hand side, this is a perfect square trinomial. I can rewrite it as y minus 5 quantity squared. Okay, so just because I'm a guy that likes the y's on the left and the x's on the right, if it's okay with you, I'm going to make that switch right now. So I have the quantity y minus 5 squared on the left and x plus 25 on the right. What I'm going to do now is extract the square root. So I'm going to take the square root of both sides, and if I write it like this, I am wrong. I have to recall that this could either be the positive or negative. Okay, so let's see where we're at now. I have y minus 5 on the left equals the positive or negative square root of x plus 25. Well, it seems like an easy thing to do. Now we're just going to add 5 to both sides, so we get y equals 5 plus or minus the square root of x plus 25. Now, we do have a problem, because if I leave this plus or minus symbol here, I have two different outputs for a single input. I'm either adding a number to 5 or I'm subtracting a number to 5, and that is a problem. So we have to choose one of these. The reason it's a problem is because it's not a function. I get two different outputs for one input. So I have to choose either the positive or negative. And the way we're not going to choose it by a coin flip. You're not just going to randomly pick one of those two. What we're going to do is look back at this idea right here. Okay, if you recall, we talked about f inverse, the output of the function, has to be greater than or equal to 5. The only way that can happen is if we choose the positive version here, 5 plus the square root of x plus 25. So let's rewrite this now. Y equals 5 plus the square root of x plus 25, and that is my inverse. Okay, so that is an algebraic way of thinking about the inverse of a quadratic. I'd now like to show you a graphical way to think about the same thing. All right, so we have y equals x squared minus 10x for x greater than or equal to. All right, so let's think about this inverse graphically. If I have y equals x squared minus 10x for x greater than or equal to 5, let's take a look at the graph of that. Here I have the graph of x squared minus 10x, but I don't have the greater than or equal to 5 part. So let's see if I can do this. I want to say I'm going to graph x squared minus 10x, and I'm going to do this such that x is greater than or equal to 5. Oh, take a look at that, folks. Now we have just half of the graph. Okay, and that may be something you're not sure how to use on your how to do that on your calculator, how to restrict the domain. I just showed you on the TI Inspire here. That'll work whether you're using the TI Inspire CX or the CX CAS. If you have a TI-84, I'm going to have to look that one up in the manual. You could do that as well because I don't recall from memory how to do that. So let's take a look at this graph. We know it's a quadratic, and the inverse is going to be some kind of square root function. Well, think about the line y equals x. We know that the inverse of this is a reflection across the line y equals x. So that is going to be, just based on the shape, I know that that's going to open upwards, or that's going to be increasing in kind of shape like this. Okay, so how can I get that type of a shape from one of these two? Well, it's only the positive square root that'll give me that increasing function over here that'll be shaped like the reflection of this function. So that I'm going to give a shout out to Miss Bindis for that. We were talking about this earlier today, and I talked to her about this algebraic way that I do it, and then she showed me the geometric or graphical way that she does it, and I like that, so I wanted to make sure I showed you both of them. All right, let's go back and take care of this last example, F. All right, so in this example, we have another quadratic. I'm going to use a very similar procedure to what I did before with completing the square. Let's go through this quickly and see if we can catch up. There you have it, folks. Hope you're able to keep up with that work on completing the square and finding the inverse of this quadratic x squared minus 6x plus 5 for x less than or equal to 3. Notice here the highlighted step. Why did I choose the negative sign in this this relation here? It's because I needed to have the output of my inverse be less than or equal to 3. The only way I can do that is by choosing the negative option. All right, folks, that's it for page 3. Stay tuned for page 4.